Then the next protocol we have is ARP. That is ARP. What is ARP? Address Resolution Protocol. Okay. So remember, whenever you want to have communication between two systems. Okay. Now let me do one thing. Let me delete this topology. And I will take simple two PCs. See, if you want to increase the size, here is the zoom button. You can increase the size also. Like this. Okay. So let's say on PC2, I'll be using the IP 10.0.0.1. Here I'll be using 10.1.1.2. Okay. These are the IPs I'm going to use, and the mask I will use default on. Okay. So on this PC, let's go and set the IP address. Default mask. IP configuration 10.1.1.2. This is clear. IP addresses are set, so means they are directly connected. They should have the communication. Okay. So whenever, see what will happen, there is something in your PC that is known as ARP cache. There is something in your PC that is known as ARP cache. Okay. In your PCs, there is something called as ARP cache. Okay. What is this ARP cache? It stores the entries that for which IP address, what is the MAC address. For which IP address, what is the MAC address. Similarly, this PC will also have the ARP cache. And in this also, the information will be there that for this IP address, what is the MAC address. Okay. Now, initially, does your PC1 know about PC3? I mean, this PC2 knows about PC3? No. And initially, PC3 will not know about PC2, right? So initially, they do not know about each other, right? So their ARP cache will be empty. Their ARP cache will be by default empty in the initial case. Now, whenever, let's say on the PC1, I will go and I will say the command ping 10.1.1.2, right? So whenever I will give this command, what will happen? Ping works on which protocol? ICMP. So it will generate a ICMP packet. It will generate a ICMP message. In this ICMP packet, there will be some information. What is the source IP? What is the destination IP? What is the source MAC address? What is the destination MAC address? These four information will be there. Okay, more information will be there, but these are the ones that are mandatory. Okay, now PC2 will see who is the source IP. Who is the source IP? 10.1.1.1, because PC1 this PC2 knows about its own IP address. So source is 10.1.1.1. Correct. Destination IP we have mentioned in the comment that I want to ping which IP address? 10.1.1.2. Source MAC address. Let's consider the MAC address for this PC is M1 and for this PC is M2. So PC1 knows its own MAC address. So it will say MAC address is M1. What about the destination MAC address? Now, initially your PC2 doesn't know about PC3. Correct? So what it will do? It will check in the ARP cache. Do I have an entry in the ARP cache? No. Means this information is missing. Now, how to get this information? How to get this information? So for getting this information, what your PC will do, it will hold this packet. Okay, it will not forward this packet. Instead, it will generate one more packet. That packet will be known as ARP, Address Resolution Protocol. Okay. So there are two types of messages in your ARP. One is the ARP request and second is the ARP reply. So the request will ask for the MAC address and reply is just C. PC2 will send a request, PC3 will reply. Okay. And your ARP request, this ARP request is always a broadcast. What it is? ARP request is always a broadcast. So again, the information will be there. Source IP, destination IP, source MAC and destination MAC. Source IP will be, who is generating the request? PC2, right? So 10.1.1.1. Okay, you are getting confused in this IP numbers. Let me say this is PC1 and that will be PC2. So that will be easy for us. Okay. So PC1 is generating the request. So IP will be 10.1.1.1. That is the source. What will be the destination IP? Correct. Source MAC M1. Destination MAC. What type of message it is? Broadcast. Means the last MAC address. What is the last MAC address? F. Because MAC address also hexadecimal, right? So means all FF 12 times. That will be your destination MAC address. Now what will happen? Is the information complete in this packet? This information will travel this side to the PC2. Now what your PC2 has to do? As soon as this ARP message reaches your PC2, what your PC2 will do? First of all, it will check from where the packet has come. 10.1.1.1. Okay, make an entry. That the IP is what? 10.1.1.1. Okay, what is the source MAC address?
M1.
M1. M1. Done. What is the destination? 10.1.1.2. Is it correct? Yes, it is correct. What is the destination MAC address? FF. Okay. So means this is a ARP request. So PC2 will reply to this request. So PC2 will also generate a reply packet. And this will be ARP reply. Okay. In the ARP reply, PC2 will say source IP, destination IP, source MAC, and destination MAC. What will be the source IP? 10.1.1.2. What will be the destination IP? It is replying to this packet. So means what will be the destination? Correct. 10.1.1.1. What will be the source MAC address?
M2.
M2, because PC2 knows its own MAC address. So source will be M2. What will be the destination MAC address? Now it will check in the ARP cache. That for 10.1.1.1, do I have an entry in the ARP cache? Yes, I have an entry. What is the MAC address? M1. M1. And this ARP reply will come this side. This is the request. This is the reply. Okay, this reply will come this side. Now what your PC1 will do, it will check. What is the source? 10.1.1.2. Okay, I have received some information from 10.1.1.2. What is the MAC address for 10.1.1.2? M2. Done. Okay, now it will come back to this packet. It will check, okay, what was the information missing? Destination MAC, for which IP address? 10.1.1.2. Do I have the MAC address for 10.1.1.2 in my ARP cache? Yes, I have now. What is the MAC address? M2. So now this will be replaced with M2, and now this ICMP echo request will forward. Okay. ICMP echo request. The ICMP echo request will forward. And then again, your PC2 is going to reply to this request with the same set of things like source IP, destination IP, source MAC, and destination MAC. So now they already have the MAC address for each other. So now no more ARP process will happen. The ARP process will happen only one time in the beginning just to get the MAC address. So now if I ask you what is the requirement for ARP, why ARP is used?
Broadcast.
Not to broadcast. What is the use of ARP? Earlier, we were not having the MAC addresses. So to get the MAC addresses, we need ARP. So your ARP is going to resolve your IP address to MAC address. Okay, or you can say your ARP is used to get the MAC address for a known IP address. If you know the IP address, ARP will get you the MAC address. This thing is clear? Okay. Now the same set of things I will show you practically. See, initially if I show you the ARP cache, initially if I show you ARP-E, what it is saying? This is the command to check the ARP cache of the system, ARP-E. So right now, no ARP entries. What about the PC2? ARP-A, because initially they will not know about each other. Okay. Initially, they are not going to know about each other. Now, sir. Now we want to capture the packets. Okay, I will give the ping command, but by default, I will not see the packets. See, there are two modes in your packet tracer. One is the real time and second is the simulation. Okay. Let it divide, let it be black. Okay. So now you can see we have two things here. One is the real time and second is the simulation. Okay. So in the real time, you will not be able to see the packets. If you want to capture the packets, see what all the packets are getting generated, okay, and what all the information is there inside the packets. So you have to go to the simulation mode. Okay. So if I go to the simulation mode, it will tell me that what all the protocols it is going to filter. Means what all the packets we are going to see. Okay. So just go to the simulation mode. Now see, if I go to the PC1, if I go to the command prompt, now I will give the command ping 10.1.1.2. Hit enter. How many packets are generated? What are the two packets that will be generated? One will be the ICMP. And since ICMP will not have the layer 2 information, one ARP will be generated. See. What type of packet? What type of packet? Out of these both packets, which packet will travel first? ARP will travel. First of all, check the ICMP. In the ICMP, we have source IP, we have destination IP. Do we have the layer 2 information? No. Okay. See what it is saying? The next hop IP address is a unicast. The ARP process looks it up in the ARP table. So initially, will it have the MAC address in the ARP table? No. So it is saying next hop IP address is not in the ARP table. The ARP process tries to send a ARP request for that IP address and buffers this packet. Buffer means it will hold up this packet for some time. So first, your ARP packet will travel. And if you see this ARP packet, you see here, what is the source IP? 10.1.1.1. What is the destination IP? 10.1.1.2. If you see the source MAC address, this 00E0F9EA9972. This is the MAC address of your PC1. You can check. Click on the PC1. Go to the config. Go to the interface fast Ethernet and you can see 9972. This is the MAC address for PC1. What is the destination? Yeah. All F. Why? Because your ARP request is a broadcast packet. Now first your dark green packet. That means your ARP packet will travel. See? Done. Now since your PC2 has received this ARP packet, it will create an entry in the ARP table. So earlier we said no ARP entries. Now if you check, it has taken up the MAC address for 10.1.1.1. This is the MAC address. right? Now what will happen? It will reply to this packet. So when you see the reply, this is in layer. In layer means inbound packet, incoming packet. So the incoming packet was from 10.1.1.1, destination was correct. Now see the outgoing packet. See, who is the source IP? Who is the destination IP? Correct. Who will be the source MAC address here? PC2, that is 50B7. Who will be the destination MAC? You see 9972. Correct. Okay. Now what will happen? This ARP reply will go here. And as soon as this reply will go, your ICMP packet will come back up again. Came again. If you open this packet, now it has the layer 2 information also. Okay. Now this is a bug in your packet tracer that here you are not able to see the layer 3 information. But that information you can see if you go to this details of the packet. Okay, here everything you'll see. Who is the source IP? 10.1.1.1. Who is the destination IP? Correct. What is the source MAC address? 9972. What is the destination MAC address? 50B7. Okay. And now you see. Did we receive any ping reply yet? No. Why? Because the request has not gone. So this is the ping request. First request, first reply. And you see here now. Now second request will go. This is again ICMP. Second request, second reply. Check again. Third request, third reply. Correct. Then we have fourth request, fourth reply. Okay, do not focus on the color of the packets. They will randomly change. Okay, there is no fixed color for a particular protocol. That is random. All four replies received. And we see. And if you see ARP-8, so it has created an entry for 10.1.1.2 with the MAC address, this one. Is that clear? Okay. Now see, ARP, address resolution protocol. So address resolution protocol is a communication protocol used to discover the data link layer address. Data link layer, which layer? Layer 2. What is the layer 2 address? MAC address. That means full form of MAC, media access control. Okay. So it is going to discover the MAC address associated with an IP address. That is the internet layer address or layer 3 address. So if you know the IP address, your ARP will get you the MAC address. Or you can say ARP is used to resolve IP address to MAC address. Is that clear? ARP is a request and response or request or reply protocol, correct? In which one device is going to send a request to another device asking for some information. That means asking for MAC address, to which the other device will reply with the required information. If first device is asking for MAC address, second device will reply with the MAC address. It is a message exchange pattern, and the ARP packets are encapsulated by link layer, means data link layer, and are distributed only in a particular network. ARP will never see, ARP is a broadcast. So we'll never going to leave a network, because to communicate between two different networks, we will need a router. And your router never forwards a broadcast message from one network to another network. So it will never leave a particular network. Will be distributed only in one network. Correct? And as a result, your ARP is said to be a link layer protocol. So ARP is which layer protocol? Layer 2 protocol. Is that clear? Okay. Then this is your ICMP packet, how it looks like. There will be source MAC, there will be destination MAC, there will be source IP, destination IP, there will be protocol number, and there will be a type field. These are the information in an ICMP packet. Okay, let me show you. Say like this is an ICMP packet, right? If you open this packet, this is the ICMP header. So we have one type field here, correct? And we have other fields. Okay. What other fields we have? We have source MAC address, destination MAC address. Then we have source IP, destination IP. Okay. So in the IP packet, this much information will be there. Okay. So if you see here, what all the things are there? Source MAC, destination MAC, type, source IP, destination IP, and protocol. So the protocol number for your ICMP is 1. So protocol number is 1. Source IP, destination IP, who is the source, who is the destination? Source MAC, destination MAC, their MAC address is type field. This type field is going to define whether your message, ICMP message, is a request or reply. For request, the type will be 8, and for reply, 0. Okay. Now see here. When PC2 sent this packet, PC2 sent a reply or request? Who sent the request? PC1 sent a ICMP echo request, and PC2 sent the reply. Let's see here. If I open this message, what is the ICMP packet type? 0. So if the message type is 0, what it is? Reply. Okay, let me show you another one. Okay, let me try to go and ping again. So if I will say ping 10.1.1.2, what kind of message will be generated? Okay, 1 minute. Let me go real time. Back to simulation. See, now they already have the MAC address, so no ARP will be generated. That will be only one time. What type of message it is? Request or reply?
Request.
So what will be the type code?
8.
8. You see ICMP message type? 8. Okay. And when the reply will come, this PC is going to reply. Click here. This is the packet that was incoming, was having the type 8. Now this is the packet going from PC2 to PC1. What will be the type? 0. So if type 8, request, type 0, reply. Okay. This is clear. This is how an ARP packet looks like. So before the ARP header, there will be always an Ethernet header. In the ARP, you will have the source IP, destination IP, but in the Ethernet, you will have the source MAC and destination MAC. Again, in the ARP also, we have ARP request and ARP reply. So ARP request and reply, they are defined with the opcode value. Opcode value for request is 1, reply is 2. Okay, see here. So let me do one thing. Let me clear the ARP. Okay, so you can give the command ARP-D. And now if you check again, ARP-A, no ARP entries. Correct? Now what I will do, if I try to ping, this PC do not have the MAC address for PC2. So it will generate a ARP. Okay, let's go back to simulation. PC1, command prompt. 2 messages generated. One will be the ICMP. Second will be the ARP. ARP will be ARP request or reply? Request. Now see. If I go to the outbound PDU details, okay, or here also you can see that first what it is saying, Ethernet header, and after that Ethernet header, ARP packet, right? So first of all, we will have Ethernet header, then we will have ARP header. In the Ethernet header, if you check here, in the Ethernet header, source MAC address, destination MAC address. In the ARP header, source IP, destination IP. Same things. Source MAC, destination MAC, source IP, destination IP. There will be more information like type field. Okay. See, if more information you want to see, you have to go to the details of the packet. Okay. And now you see here, lots of information is there. So this message is a ARP request or reply? Request. So first of all, check what is the opcode value here. 1. Correct? Opcode value is 1. So if the opcode value is 1, that means it is a request. Okay. Then all the other things like you have destination MAC, you have source MAC, Okay. Now, sometimes one more question is asked that in your ARP also you will have source MAC and destination MAC, right? Source MAC will be the same PC1 MAC, but destination, does your PC1 know that what is the destination MAC address? No. So for defining unknown MAC address, it will say 000. Okay. Broadcast is just the Ethernet, but your ARP will have the MAC address 000. Sometimes in interviews it is asked. Okay. That in an ARP request, okay, in an ARP request, in ARP header, what will be the destination MAC? So when they say in the ARP header, it will be 000. When they ask about Ethernet header, it will be all F, broadcast. Okay. So what is the opcode value for the request? 1. And if you go, now this PC will reply to this ARP request. Open up this packet. This is the reply. So in the outbound, if you check, what is the opcode value here? 2. Okay. And in this type field, okay, in this type field, basically in the Ethernet header, the information, what information is there? That inside this header, what kind of protocol is there? This type field is going to tell this. Okay. And for ARP, this value will be 0x0806. This is for the ARP. Okay. So right now, if I show you, here in the type field, you see, this is Ethernet header. In the Ethernet header, in the type field, what is the value? 0x0806. Correct? That means ARP. So inside this, there is ARP. Okay. And now both things are there: source MAC, destination MAC, source IP, destination IP. Clear? So your ARP is clear. Opcode values are clear. Then if we discuss different types of ARP, okay. So we are, I think I gave this task, types of ARP. No? Okay. Huh?
Difference between ICMP protocol and ARP.
I forgot. Okay, no problem. ARP is basically 5 types. ARP, then we have reverse ARP, then we have inverse ARP, then we have proxy ARP, and we have ZARP. These many types of ARP is there. Okay. This is the normal ARP, that is resolving IP to MAC. Okay. These two are reverse of this thing. That means MAC to IP. Then we have proxy ARP that we'll discuss tomorrow, and ZARP that we are going to discuss here right now. Okay. These are the different types. Now, IP to MAC you understood. Now, can you tell me one case where you have the MAC address and you want to know the IP address? Where you have the MAC address already, but you want to know what is the IP address.
Reverse ARP.
Yeah, reverse ARP, but what is the case? When you have the MAC.
Router.
Okay. How?
Because router doesn't go faster. It provides its own name.
Happens in case of DHCP. What is DHCP? Do you know? Protocol used to automatically assign the IP addresses. So when I say, I go to my system and say, take IP from the DHCP, my PC has the MAC address. Does it have the IP address? No. So it will ask for IP address. So in that case, okay, these are used. But see, earlier reverse ARP and inverse ARP were used, but now reverse ARP has been replaced by your DHCP. Before DHCP, reverse ARP was used to get the IP address. Okay. So your reverse ARP has been replaced by DHCP, and inverse ARP, it was used in the frame relay networks. and the frame relay technology has been replaced by MPLS. Okay, so right now you do not need to worry about these two types of ARP, not used. These are not used. The one used ARP, proxy ARP, and ZARP. So ARP we have discussed, ZARP we will discuss, and proxy ARP is for tomorrow. Okay, ZARP. See, ARP we came to know that, okay, IP to MAC translation is going to do. It is going to resolve IP to MAC. Now, ZARP. Now, sometimes what happens, let's say if you set an IP address in your system, right? What will happen? Before accepting that IP address, your system will check whether the same IP is being used inside the network. Okay, means it will try to find out the duplication of the IP address, whether the same IP is being used inside the network. Okay, how it will send out? Using the GARP. Okay, so for GARP, there is no request. GARP is just a reply. There is no GARP request. GARP is only the reply. Means if I have received some IP address, I will announce that, okay, guys, this is my MAC address. So I have this IP now. I'm using this IP. Okay, this is how they're checking for duplication. So if I'm announcing my IP address and MAC address, and if someone else is using the same MAC address, they will also say, no, I'm using this IP address. Okay, so to find out duplication, we will use the ZARP. Not we, but your system uses the ZARP. Okay, they are going to send ZARP, and with the ZARP, they are going to check for the duplication. Okay, so your ZARP is a ARP response, not a request. That was not prompted by an ARP request. There is no ARP request for the ZARP. The ZARP is sent as a broadcast because I want to check in the entire network whether someone is using the same IP. So I will broadcast. So your ZARP is what? A broadcast message. As a way for a node to announce or update IP to MAC mapping, because I have received some IP address, I will announce that, okay, this is my MAC address and I'm using this IP address. This is how I'm announcing. Now, I will also try to get the duplication, because if someone else is using the same IP address, they will also announce that, no, I'm using this IP address. So they will also send a ZARP. Okay. So this is how the duplication is found out. And the redundancy purpose, this you will understand when we are discussing about the FHRP. Okay, during that protocol. But use of ZARP is simply what? To announce IP to MAC mapping. Or you can say to check whether the same IP is being used inside the network. Okay, for example, let me show you. What is the IP address on PC2? Correct. Now, if my PC1, if I go to my PC1 and if I set the IP address to 10.1.1.2, okay, you will see what it says. This address is already used in the network. How does it came to know? Using the ZARP. It sent a broadcast ZARP and it received a reply also that no, someone is already using this IP address. Okay, so it said no, this IP is already being used inside the network. Is that clear? Yes or no? Clear, right?
So, the ARP is already learned it would have been immediately sensing it to the background.
Yeah, broadcast.
Yeah.
It's a broadcast. And since these are only two PCs, so won't take long time. Okay. But eventually they are going to send the ZARP. Okay. In the real scenario, let me show you. No, I cannot change the IP address of my system. I will get disconnected.
No, but you will see logs. You will see logs.
No, if you are using something like packet capturing tool like Wireshark, there you can see. In the packet capturing tools, yeah. Duplicate, no, ZARP entry.
Yeah.
ZARP entry will be there. Because they are capturing all the packets. So when you will send or receive a ZARP, they will capture. There you can see.
But here it is sent as broadcast.
Yes, ZARP is a broadcast.
I will send a broadcast to all of them.
Yes.
And you will also send a broadcast if both of our IP matches the same.
See, like you will announce that, okay, I'm using this IP address. So if I'm already using that IP address, I will reply to you. Because see, in the ZARP message, what happens? Let's say, as of example now, your PC1 was having the IP, or on the PC1, we changed the IP, right? And PC2 was having the IP 10.1.1.2, correct? And on the PC1 also, I sent the IP 10.1.1.2. Now what a PC1 will do, it will generate a ZR. Okay. In the ZR, it is going to say same things: source IP, destination IP, source MAC, and destination. Source IP and destination IP, they will be the same in GR. Okay. Means source will be 10112. Destination will be 10112. Source MAC, let's say this is M1 and this is M2. So this will be M1, this will be M2. Sorry, not M2, but this will be broadcast, so all F. Now what will happen? This message will be broadcasted in the network. Now when PC2 will receive this message, PC2 will check that, okay, this is for who? 10.1.1.2. So PC2 will see, okay, this is for me only. Now it will reply. So it will reply. So when it will reply, the source will be itself 10.1.1.2. Who will be the destination? Who will be the destination? In this packet, who is the source? They will become the destination. So again, correct. So this is how it is going to reply back to this PC. And it will come to know that, okay, someone is already using this IP address. In the ZRP, you're sending a response. If you receive a reply for ZR, that means the same IP is being used in the network. This is how they come to know. Okay. This is clear about ZR for checking out duplication, whether the same IP is being used inside the network or not. And also to announce that, okay, I'm using this IP address. Okay. This is clear. So any doubt in today's part, the basics of router, packet tracer, and only small concept we have seen, ping, ICMP, and ARP. Any doubt?
Then router, suppose I set my password 123. If my friend wants to change the password, suppose I want to change my password in global configuration mode, I have to set a new password.
So simple, enable password and new password.
It will
Replace the old password. Correct. Okay. Whenever you want to set the next new password, just give the same command in the global configuration mode. Old password will be removed, new password will be set. Okay. Anything else?
While I'm in global configuration mode, if my friend change no enable password or no enable secret, it will
remove the password.
Anybody
See, router doesn't care who is giving in the command. Your router is not going to care who is typing in the command. If the command is there, it will take effect. Okay. Guys, online people, any doubt?
Password recovery and all, you see.
I'll show you. Don't worry. See, password recovery, I'll show you if someday we have time. Because during the password recovery, there are chances that you might wipe out entire configuration also. Okay, so it will take up some time to explain everything, that how to recover password without compromising the configuration. Okay. So, any doubt in today's part? No? Clear? All right. Online people, no doubt?
No, sir.
Okay, I'll stop the recording.